Not really. So this was our quiz. How many of you think you rocked it? Raise your hands. Wow. If you sit towards the front, you had a good shot, and then one of you in the back feels good about it. All right, here we go. So how many grams are in 7.6 moles of HF? We'll work through every single one of them, but if you think it's easy, that's great. Just remember, please follow the process every single time. So I'm going to take my given. I'm going to do them all right in this tiny little space. So 7.6 moles of HF goes on top. And then what has to go on the bottom right every single time? It's always the what? The moles, or the unit that is here, always goes down and over. So moles of HF. And then what has to be on top? The grams, all right? Because that's what I'm solving for. So grams of HF are just 20. Is that correct? All right, so 7.6 times 20 is like 152. Is that right? Wow. I hate being so smart. It's 152 grams. All right, if you got it wrong, do you know what you did wrong? What did you get? Fine. How many of you know you got 152? Raise your hands. Okay, that's not bad. The middle is definitely bad, but the rest of the rows are doing great. All right, next, number 2. How many moles in 458 grams? So you'll start with 458 grams. So what unit goes down there? Tell your lab partner right now. What unit? Grams. Which means what unit's on top? Moles. For every 1 mole, you have how many grams in kBr? 119. Is there anyone willing to admit they have no idea where the 119 came from? All right. That is 3 people. That's plenty. So those that don't know where that's coming from, on your periodic table, you'll find a square for each element. Inside that square, you'll find the symbol, you'll find the mass, and you'll find the atomic number. When we find this number, we are adding the parts with the bigger numbers. So K was 39, BR was 80, right? And I don't know, is that 40? 35? All right, so we just add the 39 and the 80. That's where the 119 came from. 458 divided by 119 is what value? 3.85? And that's moles. Okay, who had 3.85? Raise your hands. That's all right, not bad. Okay, number 3. Actually, let's undo this a bunch. Oh, crap. Number 3. All right, molarity is the one where we put something in all 4 of the places, correct? So when you solve for molarity, please remember, you start with exactly what I gave you. I gave you 28 grams in how many liters? 0.5 liters. And then we have to get moles over liters, right? So we know moles must go on top, which means what has to go on the bottom? Grams. So we find kBr again, 119. And 1 is right there. Okay? Then you multiply the 2 bottoms and divide 28 by that answer. And was this the 0.5? 0.47? Did anyone use my 1 over button? It's nice, huh? Here, find your paper. Let's see if we can figure out what we're doing wrong. Okay, 0.47 molarity, or molar. Then number 4. Everyone was supposed to be corrected. Then the fourth one. Shh. We want how many grams of LF are needed to make whatever it says. So here we go. We have this 2.5 liters and 0.5 capital M. If you remember, the capital M means moles per liter. This we already used also, didn't we? No, we didn't. That's 24, 26, thank you. All right. So which one of these three numbers, because remember this one's that one. Wow, it's hard left-handed. Which one is alone? Meaning not in a fraction. 2.5 liters, right? So I put 2.5 liters right here. What has to go down there then? Liters. What do I have with liters? 0.5 moles per 1 liter. That means what unit goes down there? 1 mole. And then I need grams, which was this one. So you take 2.5 times 0.5 times 26. 30 something? 32.5? All right, how many of you are pretty sure you got 100%? Raise your hands. 1, 2, 3, 4. What's wrong, Ashton? You look fired up. It is not a tiny brain. It's probably within 5% of everyone else's brain size. Okay. If you will give me 5 fingers if you think you got this perfect, 1 if you're completely lost, and remember you can't use your middle finger if it's just a 1. So show me where you're at and hold them up for a minute. Yeah, that's why I'm wearing this ridiculous thing. Chance is good. Sleeping means you got it 100%. Okay. That everybody that I saw, all but 2, had a 4 or a 5.
What? Me and Bridger both had 3. I had a 3 too. So. I had a 2.
Okay, I can't count. The majority of people had a 4 or a 5. We only had 1. 1. We had a lot more 3s than I thought. 3 and 4, when you're just looking fast, looks like the same number.
I had 2.
You had a bunch out, and you moved them when I looked at you. You're trying to get me to do the game, huh? You're like, oh, I have 3.
It has to be below the waist.
Yeah. Whose waist?
Mine.
Okay. All right. So, don't touch it, please. It's a blade that will certainly cut off the edges. Come on. All right, will you please look at the screen and then, right here, then turn to whatever page this is. Danielle, what page we got? 16. Okay, we should be ready to test on Friday, FYI. This.
Hey, do you know what day the ACT is?
No. All right, so please pay attention. Tell your lab partner real quick, when do we test?
Friday.
Friday. So that's 2 days. Don't come. You can continue to fail. That's your choice. It's America. Here we go. So we learned that there were 3 ways to quantitatively describe concentration. The first of those 3 was molarity, and that's what we learned yesterday. And the second one is called percent concentration. We'll learn that for the next few minutes. And then parts per million.
What was that?
Parts per million is pretty easy. Is everything okay? Okay, here we go.
Doesn't sound like it.
Smooth. When you're not here, this class goes perfect. It does not go well when you're here. Do you know what that means for your citizenship?
What are you talking about?
I'm talking about you being a distraction. First blank. Percent concentrations can be used in the 3 following ways. All right, so percent is your first blank. The first is mass over mass. Now look, percent concentration is not hard. If we were going to do percent concentration of just like the amount of boys in this class, we would just count how many boys there were, divide by the total number of people, and multiply by 100, right? That's all you're doing. We're taking a part, dividing it by the whole, and multiplying by 100, and that will give us our value. So there are 3 ways to do it. The first is when we find the percent mass over mass, and it's the number of grams of solute per grams of solution expressed as a percentage. Now, of the 3 of them, this is the only one that is a little bit tricky, because sometimes when you are given mass over mass, it gives you the mass of the solute and the mass of solvent. If it gives you those two, has it given you the mass of the solution? No, you have to add them yourself. Now, this is the only one that happens on. The rest of them, it will always give you the solution. But be careful on this one to make sure you have the denominator be the mass of the solution. So here we go. It's the grams of solute over the grams of solution again, times 100. Okay, so right off the bat, we're going to go to the sample problems. And you'll see the first one says calculate the percent concentration. And then it tells you M over N, so you know to use this one, of 2.5 grams of copper 2 sulfate. Now what's nice here is we don't care that it's copper 2 sulfate. We just care that it's 2.5 grams. That's your solute in, am I reading the wrong one? 25? Okay, thank you. 25 grams of copper 2 sulfate, and it tells you it's in 247, no it doesn't, 975. I'm doing the next one in my head on accident. You'll see. It's in 975 milliliters of water. Now, you need to know something for the rest of this lab book, and it's that 1 milliliter of water equals 1 gram of water. So really, in number 1, how many grams of water is it giving you? 975. Is that the mass of the solution, though? You have to add them. So the denominator for this one will be 975 plus 25, or that's 1,000. And you multiply by 100. And the answer you have seen before. Oh, it's 2.5. See why my brain has been confused a little? Oh, they're not on here, so that's fine. But the answer to number 1 is 2.5%. Will you try the second one? No, that was this one.
Ooh.
Nope, for percent and part per million, we don't care what the stuff is. We just care how much amount of the stuff there is. So you don't ever have to use the periodic table on these. So the second one is just like the first one. Just one more reminder. It is only mass over mass when you have to add the denominators, because the rest of the problems will always tell you what the solution is. This one occasionally only tells you the solute. Okay, in part B, we have mass over volume. It will be the same math, except we don't have to add. Mass over volume is the number of grams of solute per milliliter of solution, expressed as a percentage. So we have grams on top, we have milliliters on the bottom, and you multiply by 100. So if you will look at numbers 3 and 4, this time don't add. Number 3 says you have 48 grams in how many? Whoops. You do not add the denominator, because if you read the problem, it will tell you it's 250 milliliters of solution. Yeah, on the test it will tell you which one to use. And you don't have to memorize these either, because they're listed on your periodic table. I don't know if I pointed this out, but on the inside on the far left are all your equations, and they're about right here somewhere. Oh, right there. You convert it, times it by 1,000, so 2,000. It's the same. Moving at 3 is 1,000, not 100, because the zeros represent how many places you move it. That makes sense? Yeah. You multiply it or move it, you add 3 zeros, so it's 2,000 milliliters. Okay, in the next one down, you have to convert your liters to milliliters. 2 liters becomes 2,000 milliliters. So you just take your numbers and divide. You had 56 divided by 2,000.
Show my work.
What? Okay, times 100. These aren't that hard. So if you're like, man, how are we going to get 2 things covered in 2 days? They're not that hard. Okay, the next one we'll get tomorrow. It's the same thing. It's just milliliters over milliliters.